Everyone, welcome to Cool Earth. My talk today is in association with the Change and the Power of One campaign. It's funding from the Department of the Environment, from the EPA and from SEAI. The talk is very much trying to explore why we need to address climate change in a new way. In other words, we need to develop a climate for change to really come to an understanding of the implications of this really significant issue of our time. And really what I'm going to try and concentrate for the purposes of the talk is the link between energy and climate and how we need to reassess and re-understand this connection and how we actually adjust our society accordingly. It all boils down to just one tiny little molecule. This is the carbon dioxide molecule, and this has some very unique properties. It has the ability to hold heat, and I'll touch on that later on in the presentation. But really, we are the first generation to understand the implications of this molecule and its unique ability to create warming in our atmosphere. And as a result, we are actually going to have to do something about that. We need to understand the science of it, and we need to adjust the way we live in order to lessen its impacts into the future. It's a complicated story. There's lots of very interacted layers here. We have human activities which are affecting the chemistry of our atmosphere. As a result of this changing of the chemistry, we're seeing alterations in the climatic characteristics, and they're posing significant threats for human society. So if we take a look at each of those steps along the way, human activity, what we're doing there is essentially we're burning fossil fuels and we're changing land use. And all of the associated activities with those are releasing greenhouse gases into the atmosphere. And this releasing of greenhouse gas is adjusting or altering the chemistry of our atmosphere. Because we have more of these greenhouse gases in our atmosphere, we're noticing changes in the climatic system. This is seen in things like cloud cover, precipitation, temperature, lots of different indicators to show that our climatic system is altering. And behind all of this changing climatic system are significant threats to our society, to our economy, and to the natural environment. So it's a highly complex, interrelated story. But at its core are two things: the burning of fossil fuels and the changing of land use. As a result of this, we're releasing greenhouse gases into the atmosphere, we're disturbing the carbon cycle, and this is enhancing the greenhouse effect. So we're seeing this warming of our climatic system. Who can we blame for all of this? Well, we only need to go back to 1750 or thereabouts, and Mr. James Watt. If we want to point the finger, when he invented his steam engine in the Industrial Revolution, we started burning fossil fuels. We started pulling carbon out of the ground. We started burning it into the atmosphere. So carbon that was locked away 60 million years ago is now being released into the atmosphere, and this is increasing the impacts. Over the next two slides, I want to explain the science of climate change, and hopefully you'll understand how simple it is to see what's actually going on. There are two things. The first thing are the unique properties of this carbon dioxide molecule and its ability to hold heat. And in this little video clip I want to show you here, just you might understand exactly what is unique about carbon dioxide.
I can show you how carbon dioxide affects Earth's climate using this heat-sensitive or infrared camera which is purring away here, and a candle, this glass tube which is hooked up to this rather large canister of carbon dioxide gas. Now if I light the candle, you'll see that on the monitor the camera picks up the flame perfectly. Look at that, the hottest parts are glowing white. Now watch what happens when I turn on the carbon dioxide.
Just keep your eye on the flame.
The gas is invisible, so you don't see it fill in the tube, but as it comes in, you should see the candle start to disappear. There it goes. Look at that. What's happening is that the carbon dioxide in the tube is effectively trapping the heat.
The candle's warmth no longer reaches the camera, Instead, it's absorbed by the carbon dioxide inside the tube.
So that's one side of the story. We have this unique quality of carbon dioxide and its ability to hold heat, like putting on an extra blanket. And the other side of the story is the concentration of carbon dioxide in our atmosphere. And this has been measured since the 1950s in Hawaii, where year on year they have measured the concentration of carbon dioxide in the atmosphere. And we can see two things in this graph. The first really is our planet breathing. This is the carbon cycle, and you can see that saw shape. In the summertime, all of the plants grow and put on leaves and absorb carbon dioxide out of the atmosphere. And in the winter and autumn, those leaves fall off and the plants decay into compost and release that carbon dioxide back out into the atmosphere. This is the beautiful breath of our planet, 2 breaths every year, one in and one out. But the second thing that's in this graph, and this is the story of climate change, is the concentration of that carbon dioxide molecule in our atmosphere. And we can see here the blue line going up and up at about 2 parts per million every year. And that has been increasing since the 1750s when we started to burn fossil fuels, from about 280 now to 380 parts per million, 390 parts per million. And this is the story of climate change. As we add more and more of this carbon to our atmosphere is getting warmer and warmer, like the scientific experiment that I showed you earlier on. So that's really the science of climate change. Carbon's unique ability to hold heat, and we're adding more carbon to the atmosphere year on year. If we add those two things together, that's why our atmosphere is warming up. So when we come back to, I suppose, understanding that big story, we often say, but, you know, where's the evidence for this? And this is where we need to look at the other side of the climate change story. And this is the difference between weather and climate. Weather, if we think of weather, it's very much, I suppose, in the short term. Today is sunny, tomorrow is cold, the next day is hot, the next day is dry. When we look at climate, we need to start thinking in terms of years. So that sort of hot, cold, wet, dry versus autumn, summer, winter, spring. Climate is trends in weather. What happens over a period of time? And generally, the way that they look at climate is, what are the trends in weather over a period of about 30 years? So that's very important understanding. And if we look at what has been happening in Ireland over the last 40 years, if we take a look at Dublin Airport and the number of hot and cold days, we see in the first chart here the up and down of weather. That's sort of a hot year, a cold year, a hot year or a cold year. But if we average those out over time and we start to look for the trends in those measurements, we start to see climate. And here we see that over the last 40 years, we have had twice the number of hot days and we have half the number of cold days. And this is the trend in weather. And that's the difference between weather and climate. And people say, but what about this winter? What about all the snow and what about all the frost and the cold? Sure enough, that was an extreme weather event. And when we take a look at that over time, sure enough, what happened this winter was the coldest since 1968. So it was an exceptional weather event. But when we take a look at the big picture, when we take a look at the climate story behind that, interestingly enough, last January was in fact the 4th hottest January globally on record. So these are the contradictions. We get muddled by these kind of complex messages. One time they say it's cold, the next time they say it's hot. It's the underlying trend in weather is what we need to understand. And if we take a look at the global temperatures as they were for January of this year, we see, sure enough, around Europe, exceptionally cold weather. This was an exceptional weather event caused by an oscillation in the Atlantic. The scientists understand what was going on here, but we ended up with very cold, frosty January weather. But if we take a look at the rest of the world, what was happening and what made it the hottest January on record, all those places up in the Arctic, in and around North Africa, most of Asia, this is why January was in fact the 4th hottest month on record. So this is, I suppose, the difference between weather and climate. And we need to understand that the evidence is showing that as years go on, we've seen 12 of the hottest years over the last 15 years now. And it's very much looking like